All right, we will now begin a new unit about functions. And for HL, this is chapter 15 and chapter 16, both in the blue book. And for SL, this is chapter 3 and chapter 4 in your black book. Okay, so this will be somewhat of a review for some of you, for most of you actually. So we're going to talk about functions and function notation, just to make sure we're on the same page, okay? All right, so we have function notation. So functions can be thought of as like a function machine, okay? I have some input, I input it into the machine, I get an output. So for example, if the function machine says I double the input and then add 3, if I put in 4, I double it, which is 8, and then I add 3, which is 11. So that means I'd get 11, my input would have been 4. Okay. F is the most common letter to represent functions, obviously because function starts with F. So F is the function that will convert x into 2x plus 3. Okay. Here's some terminology to get underneath your belt. If I have this expression right here, notice that f is the function f. These two dots mean such that. And then you can read that x, this arrow right here, just means that x can be converted into 2x plus 3. Of course, we can write it like this or write it like such. F of x and y are often just interchangeable. They mean the same thing. They're talking about the output. Okay. And here it is very clear. F of x is the value of y for a given value x. So y is equal to f of x. All right. So on this graph here, remember that your input is always along your x-axis and your output is always along your y-axis. Okay? All right, moving onwards. Now, we were familiar with that. We've seen that before. Now, we'll kind of up the ante here. And notice that instead of plugging in numbers to this function machine for x, I'm going to be plugging in other functions. So all this means is that if I have the function and my input into the function is another function, negative x, we'll say, that means everywhere there is an x, I put negative x. And I can simplify, and there is f of negative x. Same thing with f of x plus 2. Everywhere there's an x, I put x plus 2, and then I simplify. And the last one here might be a little bit different. Again, I'm plugging in x minus 1 everywhere there's an x. But then this minus 5 is basically outside until the very end. So it's not inside the input. It's not being input into the equation. It's saying whatever this simplifies to, you're going to subtract 5 from it. Okay? And you get negative x squared plus x. So you have to get comfortable substituting expressions into another expression. In the next video, we'll talk